Hello and welcome back. This will be a video on word problems for 9-3, which are the special product characteristics of pollen. So for our first example, we have pea plants. In pea plants, the gene G is for green pods and the gene Y is for yellow pods. Any gene combination that results in a capital G is always going to be a gene, which means is always going to be green, which means G is the dominant gene. So use the Punnett square to figure out the possible combinations of offspring of pea plants and resulting pod color. Now, session A or task A says, what percent of the possible gene combination results in yellow? Well, that's real easy to figure out because over here we have 4 equal sized quadrants, and the only way it could become yellow is if both the genes are Y, Y. We can see we have 1 out of 4, and 1 out of 4 ends up being 25%. Part B, they want us to show how you could use a polynomial to model the possible gene combinations of the offspring. Well, that's relatively simple. In order to have a pod color, you have to have 2 types of genes, a G or a Y. So this G up here represents 1/2 of the genes, plus this Y here represents 1/2 of the genes. And the same thing down here. This G is 1/2 plus this Y, which is 1/2. So basically, in order to get this Punnett square, which is an area calculation, we have 1/2 of G plus 1/2 of Y, and we are going to square it. Now, in order to make those calculations a little bit easier, I'm going to change that to 0.5 G plus 0.5 Y square, and use our calculations for squaring a binomial. So we're going to take the first one, and we're going to square it, and we get 0.25 G plus 2 times 0.5 G times 0.5 Y plus, at the end, 0.5 Y squared is going to give us 0.25 Y. Now we still got like terms in the middle here, or now we can multiply these out in the middle, and we end up with 0.25 G plus 0.5 G Y plus 0.25 Y. And that's the answer to part B, but we can also use this to figure out the probability of getting a green or yellow pod. As we can see, the only one that has a Y by itself is 0.25, which again is 25%. And remember, if it has a G gene in it at all, it's going to be green. So if we add these two together, we end up with 75% chance of being green. For regular season, Drew Brees completed 65% of his passes. The area model shows the possible outcomes for 2 attempted passes. And the first thing you'll notice about this area model is, yes, we've got 4 quadrants or 4 sections, but the sections are not all equal in size. And that's because he's getting 65% complete and 34.5% incomplete. What percent of the possible outcomes resulted in Brees throwing at least 1 complete pass? Okay, so 1 complete pass, that means at least 1 here, 1 here, and 1 here. In order to do that, we're going to multiply this together first. We're going to come up with a polynomial expression that shows the attempted passes. So we got a C plus an I for incomplete, and a C plus an I for incomplete. So C plus I, and it's going to be squared. So follow our square pattern. So take our first one, C, and square it, plus 2 times the first one times the second one, plus the last one squared. So this will end up being our trinomial when we square this out. So in order to answer that, all we got to do is substitute in place of C and I the percentages that match. Now the question is, they're only asking for us the possible outcomes that he throws at least 1 complete pass. So the only part of the expression that we're really interested in is where it has a C. So we're only looking at this portion right here that has C's in it. So all we're going to do is substitute a C with 0.655 squared plus 2 times 0.655 times I, which is 0.345, and multiply that out, 0.881, which is about 88.1%. So even though his completed passes take up 3 of the 4 squares, which is normally 75%, he's actually got a little bit higher percentage completion because he's completing more than 50% of his passes. Part B, we've kind of already shown how can you use the polynomial to model possible results of the 2 attempted passes. Well, we already showed that, and that was c squared plus 2ci plus I squared.